Hey everyone, here's a video about solving square root application problems. So these can range from word problems to transformations, to basically anything and everything that you could possibly see. So the first one is just a basic transformation problem. So given the parent function y equals square root of x, write the new equation if it's vertically compressed by 1/3, translated 6 units to the right and 2 units down. So remember that the square root function is going to use our normal I hot over. Okay, and then also remember that the basic form for this will be y equals a square root of x minus h plus k on the outside. And remember hk, hold on, let me get rid of that box for y'all. Go away. Okay, sorry, let me clean this up real quick. Okay, remember that hk is your vertex. Alright, so the first thing that we have is it's vertically compressed by 1/3. This is our A, so it's going to go on the outside. So I'll have y equals 1/3 on the outside. Translated 6 units to the right. This one is on the inside because it's a horizontal shift and it's going to be the opposite. So when you hear 6 units to the right, you typically think, oh hey, that's plus 6. But in all reality, it's x minus 6 because x is a liar. Then you're going to go down 2 units. That's your over. So outside, so that's your k, vertical shift, exactly what you think it's going to be. So 2 units down is going to be a minus 2. So our new equation is y equals 1/3 x minus 6 minus, or square root of x minus 6 minus 2. And that is your transformed equation. Okay, next thing, you could get the question. The difference of the number x and its square root can be represented by the equation y equals x minus square root x. If y equals 0, what is a possible value for x? So what this is saying is, say you have 0 equals x minus square root of x, which one of those values will make that statement true? Now the easiest way to do this is you're going to take your answer choices and plug them in. So say I plug in x equals 1. So that means I'll have 1 minus the square root of 1. And we know the square root of 1 is 1. So 1 minus 1 equals 0. Great. So x equals 1, that works. So that means C or D could also be an answer choice. Now let's check out B by plugging 0. 0 equals 0 minus the square root of 0. We know the square root of 0 is 0. So 1 minus 0, which is 0. So 0 works. So right now, A and B both work. That means D has to be our answer. Now let's just check 4, just for fun. So I'll have 0 is equal to 4 minus the square root of 4. But where this one messes up is the square root of 4 is 2. So I have 4 minus 2, which equals 2. So it does not equal 0. That's why C is not an answer choice. Okay, the next thing that you can have is your normal application problems. So the time t in seconds required for a pendulum to complete one back and forth swing can be determined by the formula t equals 2 pi square root of L divided by 9.8, where L is the length of the pendulum in meters. Estimate the length of the pendulum that completes one back and forth swing in 2.5 seconds. So right now, what we know just from the given equation, or from the given information, is that, hold on, let me use a pen or a highlighter, is that it takes it 2.5 seconds. Okay, and then we also have t is equal to this. And then L is the length. Okay, so since we know it's 2.5 seconds, that means t is equal to 2.5. Okay, we know that. So the easiest way to do this, because I know a lot of y'all are sitting there thinking like, gosh, that's a lot of numbers for me to move around and manipulate. So the easiest thing to do is go ahead and solve it for L. So keep it as t equals 2 pi square root of L divided by 9.8. And we're going to solve for L. So the first thing you need to do is divide by 2 pi. So t divided by 2 pi is equal to the square root of L minus 9.8. Now, looking at this, what is the only function that undoes the square root function? The squared function. So we're going to square both sides. So I have t divided by 2 pi quantity squared is equal to L divided by 9.8. Now I need to get that 9.8 to the other side. So that means I'm going to have to multiply both sides by 9.8. So that'll cancel. So you get L is equal to 9.8 times t divided by 2 pi quantity squared. Now this is where I would go ahead and plug in my t. So this is equal to 9.8 times 2.5 divided by 2 pi quantity squared. Okay, I know one mistake that y'all are going to make when you put this in your calculator is you're going to put in your calculator, you're going to put 2.5 divided by 2, and then you're going to put pi. Okay, what this will do in your calculator, because this is where you're going to screw up, is it's going to take 2.5 and divide it by 2, and it's going to multiply it by pi. So that means whenever you do this, you need to put 2.5 divided by parenthesis 2 pi, close your parentheses. Hit enter, then hit squared, then hit enter. When you do this, you get 1.55, which rounds to 1.6 meters. And that's your answer. Okay, the next one. The radius of the moon is 1,080 miles. Use the formula for the radius r of a sphere given its surface area A, where r equals the square root of A divided by 4 pi, to find the surface area of the moon. Round to the nearest square mile. So again, this one has a lot of information. So we know we have the radius is 1,080 miles. R equals all of that. And then we're asked to find the area. And then round to the nearest square mile. That's where a lot of y'all are going to mess up too. Okay, so we have R equals 1,080. Okay, 1,080, that's a really, really big number. And the first thing that we're going to have to do is square this whole thing. So I would hold off on plugging in 1,080 until the very end. So I would go ahead and solve it for r equals 2 and a equals. Okay, so as I just said, the first thing that we're going to have to do is square both sides. When we do that, we get r squared equals a divided by 4 pi. Then to get the 4 pi to the other side, we're going to have to multiply both sides by 4 pi. So a is equal to 4 pi r squared, which is also the area of a sphere. So if you know the area of a sphere, that kind of helps you out. So now we're going to plug in 1,080. So a is equal to 4 pi times 1,080 quantity squared. When you do that, you get a really large number. which you can put it in scientific notation or regular numbers, that's fine. But you get 146,574,15 miles, or square miles. So that is our moon, a big moon. That's your answer. Okay, so the first thing I would always do is just go ahead and manipulate your formula. That way it's a lot less work on you, especially when you have those big numbers. Okay, the next thing, find the domain and range of y equals the square root of x plus 3 minus 2. So as I said earlier, the basic form is like this, with hk as your vertex. So looking at this one, our h, well, this is positive 3, so it's going to be the opposite. So it's going to be negative 3. And then our k is negative 2. All right, our a is positive. So that means it's just like the parent, where it's going to go like this. So now I'm just going to go straight into my domain and range. So my domain, I'm going to start with my x values, because remember, domain is x. So it goes from negative 3 to infinity. And I'm going to do my range. It goes from negative 2 to infinity. Okay, make sure you use brackets on negative 3 and negative 2, because they are included since they are the vertex. Okay, that's basically all the different types of questions that you could have with the square root applications. If you have any questions, feel free to come in and ask. Have a great night.